Thank you for giving me a voice. Today I will talk about documentation, basic and modeling. Basic of work is Emmanuel Sevineri from Vellore Institute of Technology, and idea is to make documentation for suitable for upgrading of anaerobic digestion and using also steam methane reforming. The idea is using that flue gas or dark fermentation gas can bake for biomass decomposition, and this hydrogen goes with to methane and water by reforming give hydrogen. The idea all over is the documentation, but here work is just for making using this methane we mixing with water to water shift using and flue gas without methane to get energy. Biomass is growing is renewable energy. And this is going to this that using help of Aspen Plus program. My anaerobic digestion is one of the biological decomposition. There are two kinds of anaerobic digestion. Most important is going to the documentation, which is stops on acidogenesis if inoculum is stopped and forced, if full, if unstopped and unshut, and not naturally it goes to methane. There are also suitable hydrogenotrophic and metanotrophic in compare to using to compose gas composition, and hydrogen trophic is preferred because hydrogen helps making a high percentage of methane. Because if we go metanotrophic, the trouble is that usually it's 55% of methane. Here, work of Professor Selvinraj goes into the methane and performing methane production. This shows as proximate is fixed carbon using methane. Anaerobic digestion for this case was using rice straw, and as air column served was Kodak. The Kodak was checking for 12 days and measuring the 50 minutes. The simulation was divided into three processes: biogas generation, upgrading, and hydrogen production from biogas through steam and methane reforming. Because steam and methane is traditional way, or usually by conventional form. But this is containing much energy, so this is the task for thinking how would like and is it possible or not, because it creates much energy. This shows that the anaerobic digestion is acidogenesis, and first we have this bacteria is going this for rice straw is taking in monosaccharides, amino acid, and fatty acid, and as a result, a fourth step, propionic acid is going firstly to hydrogen, and acetic acid that is transformed by to methanogenesis. It's forming methane in hydrogen. But to lab is usually 55%. And the trouble also is such process is usually instead of carbon sugar is usually endothermic, and we lack for energetic purposes have exothermic because it reduces. This is why dark fermentation is fully endothermic process. And this and use it. And this is showing the water scrubbing. Is removing of carbon dioxide from emission content and cryogenic, how to seals, and this is the trouble that it using water scrubbing is using highly pressurized water. And this is going or pressure swing method. But here is what the scrubbing process present will be absorbed by pressurized water. In steam method refining, methane reacting with steam to create hydrogen-enriched biogas. To break down hydrocarbons, mass pretreated desulfurized and methane is transformed into hydrogen and carbon monoxide. Therefore, we obtain these gases. As a result, we produce higher 80-90%, which is required to be suitable for synthesis or kitchen proposal, so for daily life. So we need to upgrade to obtain 90% minimum and low sulfur, no hydrogen sulfide initially to make suitable for our purposes, for making for energetic purposes. The aspen is used as model, as used in many cases, using different masses of all processes. There are two reactors of 1000 milliliters, and this is fit. The flow sheet is using and the feed, description, and splitter and separation for separate hydrogen sulfide and manganese and digested. Here we have several parts. The composition is separate composition, then averages the composed products into biogas and digestate. In splitter is separate gaseous component and water content present in the gas. Flash comb is removing moisture in biogas. There are three cases. The substrate use was the produced yield was Kodak was if the substrate was only countdown, the rate organic growth 0.333 and biogas yield was 353 liters per kilogram of cow dung. In case of using municipal waste, the produced yield was 540 liters per kilogram. In case of pigmalion, only pigmalion, not Kodak, there was yield 269 liters per kilogram of TF. So we have, and the rice straw give 343 to 3 milliliters per kilogram. And we see that the most important is for municipal waste. All this case was used, and experimental and theoretical, according to model, was by Aspen, and experimental was 0.35, and according to models, should be first up to 0.36 for Kodak. In case of municipal waste, there was 473, 573, which is for 30% higher than that experimental. And this, in other way using model, in case rice straw, was also much higher. Therefore, we should see that model use present lower extent, but more is how is suitable, how can correct. The model usually makes lower. So where is showing some possible potential improvements to make higher. The model validation gives simulation and simulating the proper dimensions that should be for all mixture, and this showing that the highest production was what that should be in mass flow rate of 0 is inlet for water scrubbing should be the minimum 0.54% to make for water scrubbing efficient of 99% cent fraction. So if we go lower, then it's not even to 95. So the initial for water scrubbing, we need minimum 0.65 to make almost all 90%. And in case of lower than 0.42, we get only fraction and outlet only 50%. So it's irreversible. So this method is in some time only suitable, efficient if we initially have from higher than 0.5 initial and optimally but higher than 0.65. So much more better is using upgrading of hydrogen by cooperation with dark fermentation. But it's important to design and method. And here we show that metal reforming is worse than upgrading by hydrogen. But it's important to check, to verify the model. So thank you very much for giving me a voice.